Let's move on to another type of equation called radical equations. So whenever you see an equation that involves a radical, the first thing that you're going to do is isolate one of the radicals. Then you can undo that radical by raising both sides of the equation to the appropriate power or exponent. Then you're going to solve that resulting equation. And then finally, you must always check to see if your solutions are legitimate solutions or if they were introduced and are not actually solutions. So we call solutions that appear but aren't really solutions extraneous. They're outside of the equation's realm of possibilities. So let's take a look at a relatively simple radical equation. So here the radical is already isolated. So let's undo the radical by squaring both sides. So we're going to take the square root of 5x plus 2, square it, and square the 8. Now the square will undo that radical, and we have 5x plus 2 equals 64. Let's subtract 2 from both sides, and then divide both sides by 5. So our answer appears to be 62/5. Let's check our work. So we have the square root of 5x plus 2 equals 8. Let's substitute 62/5 back into the equation. So we have 5 times x, which would be 5 times 62/5, plus 2. Then that means that we have 62 plus 2, which is square root of 64, which is 8. So notice we have 8 equals 8. That's true. So therefore our answer is indeed 62/5. So now we have the cube root of 2x minus 7 equals 2. Again, the radical is isolated, so we're going to raise both sides to the appropriate power to undo the radical. So what power will we use? To undo a cube root, we will cube both sides. So the left-hand side, we have 2x minus 7, and on the right-hand side, we have 8. So 2x would equal 15 if I add 7 to both sides, which means that we have 15 halves. Let's check our work. Substituting 15 halves in for x, we have 2 times 15 halves minus 7 which is going to yield the cube root of 8, which is indeed 2. So 2 equals 2. That's true. So our solution is indeed 15 halves. Now you might be able to do the check work in your head. That is perfectly fine, but you do want to do it. Okay, so now we have a more complicated problem. But what we're going to do is isolate our radical. So let's subtract 3 from both sides. And so we have 2 square roots of x minus 1. That will equal x minus 3. Let's now raise both sides to the appropriate power to undo the radical. So now, to square the 2, we get 4, and then to square the square root, we get x minus 1. On the right-hand side, we must FOIL. So we would have x squared minus 6x plus 9. Now, in case you're wondering where that came from, that's x minus 3 times x minus 3, which is x squared minus 3x plus 9, which is indeed x squared minus 6x plus 9. Now, we'll distribute the 4. Now, this is quadratic, so let's get one side equal to 0. Let's move the 4x and move the 4. This means that we have 0 equals x squared minus 10x plus 13. So we have the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So this gives us 10 plus or minus the square root of 100 minus 52 all over 2. That's 10 plus or minus the square root of 48 all over 2. That's 10 plus or minus the square root of 48 is 4 square roots of 3. Now in the numerator, we can factor out a 2. And so we have, after we cancel the 2's, we get 5 plus or minus 2 square roots of 3. Now how would we check this? If we were to check 5 plus 2 square roots of 3, we're going to get something pretty nasty underneath that radical. So to check this, I would suggest checking the approximations. So let's go ahead and what are the approximations? 5 plus 2 square roots of 3 is approximately, and you have to do this on your calculator, 8.4641. 5 minus 2 square roots of 3 is approximately 1.5359. So I would substitute 8.4641 into the original equation and see if it satisfies the equation. And I would substitute 1.5359 into the original to see if that also would satisfy the equation. So let's check. We have 3 plus 2 square roots of x minus 1 equals x. So we're going to approximate. So 3 plus 2 square roots of, let's try the 8.4641. And if we substitute the quantity on the left into our calculator, we get 8.4641. So that one's true. So 8 plus 2 square roots of 3 is satisfied. And if we do the same thing with 1.5359, it would also check. So what are our answers? Our exact answers are 5 plus or minus 2 square roots of 3. So now, let's go ahead and solve this equation. Let's isolate a radical. Now, we can isolate either one of these two radicals. We have the square root of x, and we have the square root of x minus 4. It does not matter which one we isolate, but I typically isolate the more complicated one. So we're going to isolate the square root of x minus 4, which means that we're going to move the square root of x. So this is going to yield for us the square root of x minus 4 equals 4 minus the square root of x. Let's square both sides. The left-hand side is just x minus 4. The right-hand side we're going to have to square. So I won't try to do that in my head. Let's just write it out. It never hurts to show our steps. We have x minus 4 equals first outside, inside, and then last will be plus square root of x times the square root of x is just x. So we have x minus 4 equals 16 minus 8 root x plus x. This resulting equation still has a radical, so let's again isolate our radical. So we're going to subtract x, we're going to subtract the 16, and this yields for us negative 20 equals negative 8 root x. Let's square both sides. So we're going to square negative 20, and we're going to square negative 8 root x. So the square of negative 20 is positive 400. On the right-hand side, 8 squared is 64, and square root of x squared is just x. Divide both sides by 64, and we obtain 25 over 4. Now how would we check that? We would check it by going back into the original equation. Square root of x plus the square root of x minus 4. Does that equal 4? So we have the square root of 25 fourths plus the square root of 25 fourths minus 4. So that yields 5 halves plus 25 fourths minus 4 will be 25 minus 16 over 4. So 25 minus 16 is 9. So we get the square root of 9 fourths. So we get 5 halves plus 3 halves, which is 8 halves, which is 4. So that's true. So indeed our answer is 25 fourths. So now here we have an equation where we have a rational exponent. It'd be beneficial to remember that if we have a power that is fractional, say 1 over n, that is the same thing as the nth root. So here what we have is 3x minus 1, take the cube root. So notice the denominator of the exponent is the index of our radical. So to undo this radical, we will cube both sides. And so we have 3x minus 1 equals 64, which means that 3x would equal 65. And so x would equal 65 thirds. So let's check it. We have 3x minus 1 to the 1/3 equals 4. That will be 3 times 65/3 minus 1 to the 1/3. Well, that's 64 to the 1/3, which is the cube root of 64, which is 4. That's true. So our answer is 65/3.